class, this is your notes for 4.3. Still working with probability, doing the addition rule. So the addition rule basically says if we're taking compound events, and compound events meaning we're combining two or more events together, like in this case A or B. If we are combining with the word or, it means that A occurs, B occurs, or they both occur. And to do that, to actually find the probability, we're going to use addition and possibly subtraction. Okay, so when you see probability A or B, some of these in the future you'll see me do probability of A, and then I'll put a U where the or is. Alright, that means the same thing. If you see me do that, it means the same as the word or, the symbol. Okay, so when we do that, our basically our formula is this. Now, the probability of A or B equals the probability of A plus the probability of B minus the probability that A and B both occur. Okay, now again, we use the U symbol for the word or, and then we use the upside down U, or some people refer to it as an N, for the and. So sometimes I'll replace and with that symbol, and I'll replace or with this symbol. Alright, so let's practice it. Find the probability that in a shuffled deck the top card is either a club or a king. Alright, so let's just remember, in a shuffled deck there's 52 cards. Okay, club, there are 13 clubs. That's the suit. And then the kings, there are 4 kings. Okay, so according to this rule, the probability of A or B. So for this example, this formula would become this. If we call A the club, right, or B a king, it becomes the probability club or king. Alright, and then that's the probability of club plus the probability of king minus the probability both. Now, king and club would just mean that one card that's the king of clubs. So the probability of a club, because there's 13 clubs and 52 cards in the deck, there's a 13 out of 52 chance that it's a club. Plus the probability it's a king, there's 4 kings out of the 52 cards in the deck. And then minus the king and the club. The 52 cards, there's one card that's a king and a club. So that's the king of clubs. Alright, and if we add it up, 13 and 4 is 17. Minus 1 is 16 out of 52. Alright, both of those have a 4 in common. So if I factor out the 4 to reduce it, I get a 4 out of 13 chance. Okay, now when you're doing this, why do we subtract? If you think about it, the 13 clubs are ace, 2, 3, 4, 5, 6, all the way up to jack, queen, king. And then these 4 aces, these 4 kings are the king of hearts, the king of diamonds, the king of spades, and the king of clubs. Well, the king of clubs got counted here with the clubs, the king of clubs got counted here with the kings. So because it got counted twice, we subtract right here, and it gets rid of that overcount. So the minus probability of A and B when you're doing these problems is getting rid of the overcount. Alright, intuitive addition rule, that just says to do it by finding the ways that A and B occur, so that each thing's only counted once. Okay, so if you don't want to use this formula, just think of, alright, there's 13 clubs and then there's 3 more kings, and that'll give you 16. Okay, so you don't have to use that rule that we're talking about. You can do it intuitively. You just have to make sure that you only count everything once. That's the big important thing with this. Alright, disjoint events, mutually exclusive, that means they don't have anything in common. So the example we just did, let's call this clubs Let's call this a king. So this overlap right in the middle would be the king of clubs. Alright, so that's what we found something that did overlap. It had something in common that belonged to both of these circles. But then if we did something like this is clubs and this is, hearts, now they don't have anything in common, so they don't overlap. So you can do use a Venn diagram to help you visualize these things, and also you can pick off probabilities from Venn diagrams, and we will definitely do some of that this semester. Alright, remember this is the notation for a complement. The complement of A, which we put an A with a line over it, is basically every outcome that doesn't satisfy A. So if A, again, we're going back to the example we've been using, clubs, then A complement, A with a line over it, would be hearts, spades, and diamonds. All the outcomes that are possible that don't satisfy this. Okay, and these things are disjoint because they can't have anything in common because they're basically opposites. So disjoint events, again, are going to be the events that have no outcomes in common. Alright, now this next couple of rules are for disjoint events. If you have two events, complements, two events that are complements, if you take their probabilities and add them together, you get one. Okay, I'm going to draw a card. The card is a club or it's not a club. If I find the probability I get a club or not a club, it's the probability I get a club or a heart, spade, or diamond. That's a certainty. I'm definitely going to get one or the other. And then based on that rule, we get these other two rules. If you want to find the probability of the complement of an event, and you know the probability of an event, you just subtract from 1, and vice versa here. Of course, these are complements of one another, so it's kind of saying the same thing. Alright, so let's say the probability of a club is 13 out of 52, which reduces to a fourth, and the probability of not a club then would be 1 minus 1/4, and then obviously 1 minus a fourth is 3/4. So that's how we use this complement rule in the middle. And again, it's the same thing going back the other way. If I knew the probability not a club was 3/4, then I could find the probability that it is a club by subtracting 1 minus 3/4, and I'd get 1/4. Okay, and then 1/4 and 3/4 adds to 1. So that's what these three rules are saying here. Okay, and again, this is notation. Just write the event, put a line over it. That means the opposite of the event.